Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. We are going to discuss here the basic concept of fluid mechanics. So first of all, we look at the learning objective. So first learning objectives to refresh the basic knowledge of mechanics. Then second learning objectives the to understand the Newton's laws of motion. So after this session, some learning outcome is there. So first learning outcome is the student will able to know the basic terms related with mechanics. Then second learning outcome is the student will be able to relate the forces and laws of motion. So first of all, we look at the structure of physics. So we know that the physics is a branch of science which concerns with nature and the properties of matter. So here the subject of matter includes the mechanics, thermodynamics, electricity, heat, radiation, sound, and magnetisms. So now we focus on mechanics. So as we know that the mechanics is an area which concerns with the behavior of physical bodies as well as the it can subjected to forces or displacements and the subsequent effect of the bodies on their environment. So basically the mechanics is having two branches, that is one is statics and second is the dynamics. So static means the body as a rest condition and it deals with different forces. So when you designing the bridges, so we consider the static forces conditions. And while designing the dynamics, the body is in motion, and then we have considered different forces over there. After studying that, we can design the IC engines. Now we move on the next condition, that is dynamics. So actual dynamics is having two branches, that is kinematics and kinetics. So while conditioning the kinematics, the forces is not considered, but body is in motion. But in terms of kinetics, the body is in motion as well as the forces will be considered over here. So the next slide indicate the dynamics. So it is branch of engineering which deals with the forces and their effects. So while acting upon the bodies in motion. So here we have two branches, the kinetics and kinematics. So in kinematics, we are considering the bodies in motion, but forces are not considered over here. So here we can other way we can say that without any reference to the forces which are responsible for the motion. The next term is kinematics. Kinetics. So it is branch of dynamics which deals with the body in motion due to the application of forces. So this is all about dynamics. Now we move to the applied mechanics. So as we know that it is a branch of physical science and practical application of mechanics. So it deals with actually describing the behavior of the bodies, or you can say in solid and fluids. So actually the applied mechanics is having two criteria, that is solid mechanics and fluid mechanics. Next term is the scalar and vectors. So as you know that the scalar is only associated with magnitude. So example is time, volume, density, speed, energy, and mass. But in case of vectors, it possesses direction as well as magnitude. So it obeys the parallelogram laws of motion. Now we know that the examples for the vector displacement is a vector, then velocity, then acceleration, force, moment, and momentum. So this is about the vector. So first of all, we discuss the distance. So distance is a measure of how far the object travels over a certain period of time. As you know that the distance is in SI unit, we consider as a meter, but in other customary units is kilometer, millimeter, centimeters. And here the distance is scalar quantity because it is only considered here the position, but here not consider the direction. Now next term is displacement. So here displacement is nothing but we are describing the object which is in changing the position as well as the direction at a certain period of time. So here also the unit is meter and this is SI unit, but in case of customary unit kilometer, millimeter, miles is available, but the displacement is a vector quantity, so therefore so here the direction is also mentioned over here, so that's why N, S, E or W here mentioned here, or can say left or right, or can say positive or negative. So this is the compass points as well as the side points. So this is regarding the displacement. Now we move for the force. So actually force is nothing but push or pull, or can say both. So here when we can use the push, when we obtain the object away from the bodies, then we can take a push, and when we can apply force to move object towards the body. So this is regarding the pull. So there's some example is regarding this: playing with guitar, sawing wood, then rowing a boat. So that is example of force. So first of all, we know that the force is a physical quantity and that change the speed, state, direction as well as dimension of object. So here in the next slide we discuss the different effect. So first is the here mentioned that object is to move from rest. So here in that figure, or you can say picture, so the that driver push the car. So this is the example of the object is moved from rest. The next example is the force can stop the moving object. So here the player is stopping the ball. So that is case of second one, that is stop a moving object. In third case, we can increase the speed by this, speeding up the bicycle. So here the force can change the speed. Then next figure indicate that the force can change the direction of motion. So here the cricket player is there, batsman, so it can change the direction by the bat. So this is the fourth compilation of this object. Then next we can change the shape also. So this is the changing of the effects by the force. The next term is the pressure. So as you know that the pressure is depends on the force and area. So here it is measure of how much force is acting on the certain area. So this is the point we discuss over here. So actually pressure is nothing but the force acting per unit area. So we can mathematically we can write is pressure is equal to force upon area. So that is nothing but P is equal to F by A. So here unit is SI unit is Newton per meter square, because force is in terms of Newton and area is in terms of meter square. So here the if it is area is small, so here area is small, that time pressure is maximum. So first of all we look at some examples. So here a solid wall block is resting on a floor. So in first condition the smallest area is occupied, and therefore here the area is small, it occupies small area is there, so that's why maximum or can say biggest pressure is there. But in second figure the area is biggest, so it can occupy area is biggest, so that's why pressure is smallest. So this is the relation for between pressure and air area is universally in a manner. So we next move to the next condition or second next problem. So here the table and brick is there. So brick is placed on a table. If it is we turn the brick on that face. So on that face, what will happen? For the face is the applying the force and pressure. So effectively the force is unchanged because force is same, but pressure will be changed because area will be changed. So here maximum area occupies and here less area occupies. That's why the pressure will be increased, right? So this is the second example. Now next, the conditions when you cut the onion, so that time the high pressure is created on a smallest area. So this is the example. Now when you increasing the force on this head of the nails, so then it can be placed easily. So this is the example of increasing the pressure by reducing the area. The next condition is when you applying the struts on the boot, it can gives extra grip because we have the distributed area of pressures. So that's why it can give extra grip. So here increasing the pressure by reducing the area. So in next example, the in a rally cars, maximally high pressures tires is there, and their tire area is narrow one because it maximum contact area with the XC road, so therefore it can gripping for the moving a car. So this is the next application. The next is the reducing the pressure by increasing the area. So whenever the stuck the tractor in a mud, so that time we consider here the reducing the pressure by increasing the area. So here we can reduce the pressure on the ground by increasing the area. So this is the example. The next example is when you reduce the pressure by increasing the that pressure pad, so it can easily carry it. So this is the next example. Now we move for next parameter, that is mass. So mass is nothing but the amount of matter present in the object. So actually the mass is always remain constant and it does not depend on the gravity. So mass is in terms of measured in kg. So this is the SI unit, but customer units are more like gram, centigram, milligram. The next slide indicate the weight. So as you know that weight is nothing but mass into gravity. So here the weight of the object is related with the force acting on the object due to gravity, right? So here the weight refers to the gravitational force on the earth surface. Then next is we consider mass and weight. So here the chart indicates the place and here indicates mass. So always remember that mass is constant but weight is unchanged according to the places. So if you consider example earth surface, if you take 1 kg on earth surface, it should be 10 newton. It is we consider 9.81, but approximately it is 10 newton, right? So if you consider for mass, so mass is, suppose weight is 1 kg, so in terms of weight it should be 4 newton. So if you consider on the moon, what will happen? If it is considered for earth surface first, if your mass is 36 kg, then weight is up to 360 newton because we multiply them by 10, so W is equal to mg, so that's why it becomes 360 newton. So this is related with earth surface. If you consider for moon surface, what will happen? So if it is mass is 36 kg, mass is same, but what will happen when the on a moon surface? So it becomes 60 newton. That means it reduces by 1/6 of earth surface. So only it is only 60 newton and here it is 360 newton. That means in a moon surface the gravity of attraction is less. In deeper phase, for 1 kg, it is weight is 0 Newton. Now we go for the difference between mass and weight. So actually mass is nothing but property of matter, and in a weight case, the weight depends on the effect of gravity. But weight, always remember that weight can be varies according to their locations. So second difference is mass can never be zero, but weight is can be zero. So it is observed in space, right? The next uh, difference is mass does not change according to the locations. Weight should be increased or decreased with the according to the locations. The next difference is mass is the scalar quantity. That means it does not depend on the directions, only depends on the magnitude. But in case of weight, it depends on both, that is direction as well as magnitude. So that's why it is called as vector quantity. So normally mass is the we can measure with the ordinary scales, or you can say ordinary balances, but weight can be measured in a spring balance. So we know that the mass is the measured in terms of grams or kilograms, but weight is in terms of Newton and kilonewton, or can say other customary units. So this is basic difference between mass and weight. Now we move for the next term, that is speed. So actually speed is nothing but the rate of change of distance with respect to time. So here the mathematically we can write is v is equal to d by t. So where the d is the displacement measured in the SI units, then t is the interval of time of SI units. So in everyday life we can expressing the speed is in terms of meter per second or kilometer per hour, or you can say miles per second, or you can say miles per hour. So here the speed is a scalar quantity, so it has not mentioned the direction. But in case of displacement, sorry, in case of velocity, the velocity is nothing but the displacement that particle of object undergoes within a speed of time. But here the velocity is having vector quantity, so here we can mention direction as well as magnitude. So the formula for velocity is v is equal to s by t. That means v is the velocity, s is the displacement, and t is the time taken. So velocity is expressed in terms of meter per second. The next, we differentiate between speed and velocity. So first difference is velocity is defined as the rate of change of distance with respect to time, but in a certain particular directions. But in the case of speed, the rate of change which object can covers a certain distance, that is called as speed. So the next difference is vector. So here velocity is a vector quantity, that means here magnitude and direction is present, but in case of speed the direction is absent, only magnitude is present over here. And velocity can be zero or negative, or can say positive, but speed is never be zero or negative. The next difference is change of direction. So here in a velocity, it minute change will also consider for change of direction, but in case of speed only it can count, it does not matter a change of direction or not. The next effect is the unit, that is if it is velocity is expressed in meter per second, speed also expressed in meter per second. The next term we discuss here, that is stress. So as you know that the stress is nothing but the restoring force per unit area for the material. So here the sigma is equal to force upon area, that is F by A. So sigma is the stress, F is the force which is the restoring the force measured in a Newton, and area is the cross section measured in terms of meter square. So this is regarding the stress. Actually, stress is categorized uh, for two terms. So first of all, we'll look at the difference between pressure and stress. So actually, pressure represents the intensity and of external force acting at a point, and stress is a internal resisting force. So only minor change is there. External force we consider here pressure, and while defining the stress we consider here the internal resisting force. This is basic difference. So here the force is only in perpendicular manner, or you can say normal, but stress, in case of that, the force is either normal or you can say parallel to the surface. So this is basic difference between these 2 points. And here in the pressure, the magnitude of the pressure at a point in all direction will be same, but here the magnitude of stress is unequal. So here magnitude is unequal. Then next, the pressure can be measured by different devices like pressure gauge, deadweight pressure gauge, but in case of stress, it does not directly measured by using any devices. So this is a basic difference between pressure and stress. But quite similarity is there. Pressure is nothing but force upon area. Again, we can say stress is also pressure is equal to stress is equal to force upon area. And if you consider for units, so same unit is there, that is Newton per meter square for pressure also, and stress also pressure force upon area. Now we move for next term, that is stress. So stress is categorized between two parts, that is normal stress and shearing stress. So while considering the normal stress is nothing but the perpendicular force acting on an area, that is called as normal stress. So normal stress is divided into two parts, longitudinal stress and volume stress. So in case of volume stress, the force is applied on a volume, it can be suppress the volume. That's why it is called as volumetric, or you can say volume stress. But in case of longitudinal stress, the only the force is applied per unit area and only change in the length will take place. So here longitudinal stress is divided into two criteria, that is tensile stress and compressive stress. Tensile stress means what? The stretching of body, that is called as tensile force, or tensile stress. And in case of compressive stress, it is opposite to the tensile stress. So we observe clearly that is tensile stress. So here the rod is there and we can apply the forces on the areas, that is cross section areas. So here change in the length takes place, right? So that is the tensile stress. So other words you can say that if the deforming the force or applied force results in an increase in the length, that is called as tensile stress. And here the pulling of rod, or you can say wires, which is applying in a equal and opposite directions, or you can say opposite forces at the both of the ends. The next is a compressive stress. So actually it is opposite to the tensile stress. Other word we can say that if the deforming force or applied force results in a decrease in the object's length, that results the compressive stress. So here when you applying the forces, the change in the length, but it should be decrease in a manner. So here example is there, when a rod or wire is squeezing by pushing it equal and opposite forces, that is called as compressive stress. So that is the example mentioned over here. The next, the part is shear stress. So shear stress is nothing but when the direction of deforming force is external, is parallel to the each other. So other words you can say that it can be slide one over the other. The faces will be slides one over the other. That is called as shear stress. The next term we discuss that then Newton's first law of motion. So as you know that a body is at rest will be remain at rest, or body will be remain motion will remain in motion unless and until the body is acted upon by external unbalanced force. So that unbalanced force means it will be friction or it can be other external force. So here the force can be balanced by different ways. So here we can see the object at rest, that time v is equal to 0, but in case of motion v does not equal to 0. So this is the Newton's first law of motion. So for example, so the ball is sitting at rest. When you kick it, then change its motion, right? So this is the first law of motion. So next example for the first law of motion is, there are two teams playing with tug of war. So when you applying the force on both side will be same, so that time the force will be acted balance one. So that balance force results no change in the motion. So this is the Newton's first law of motion. The next term is Newton's second law of motion. So it is also nothing but laws of acceleration. So first of all, we know that the relation between force and acceleration is F is equal to m into a. So here F is equal to mass into acceleration. So while considering the that Newton's laws of motion, it produces by the net force, which is proportional to the magnitude of the net force and same direction, and but the inversely proportional to the mass. So here the Newton's second law of motion associated with only the force, mass, and acceleration. So already we discussed here force, mass, and acceleration, that relation, that is F is equal to m into a. So first of all, we look at the first picture. So while applying the force, the acceleration will be increased because F is equal to a, proportional to a, that is F into proportional to a. The next picture indicate that when you applying the force more, acceleration will be more. That's why we can write as equal to force is nothing but proportional to a, that is F proportional to a. But here we are applying the force on that two cards. So here mass is less. So here speed up will be maximized. That means acceleration will be maximized. So that here the force is applied on this card. What will happen? More force is required because here the mass is more. So from this figure we conclude for that mass and force is inversely proportional. That means force is inversely proportional to mass, right? So that's why we know that F is equal to m into a. So here F is equal to m into a. Now next term is Newton's third law of motion. So here for every action there is an equal and opposite reaction. So we'll take the example of rocket. So here the reaction is the rocket moves upward because of gas is pushed downwards, that is the action. So here action takes place, therefore the reaction will be the rocket is move upward. So this is the Newton's third law of motion. So here we have discussed in the session that different terms related with force, pressure, displacement, distance, velocity, speed, etc., and Newton's laws of motion. Thank you. In next session we will discuss the unit of measurements. Thank you.